All right, we're going to be studying in this next assignment, we're going to be studying conservation of mechanical energy. And I'll define what mechanical energy is and all that in a few minutes. But I want to show you a demonstration of my faith in the conservation of mechanical energy. One of the things that turned out really well for me, genetically speaking, is my teeth. I have naturally straight teeth. They're nice teeth. I brush them, I floss them, I take good care of my teeth. And never needed braces or anything. They're just nice and straight. I would never do anything to put my teeth at risk. Okay? So you might think this is a little crazy, but here's what I've got. I got a string connected to this pipe right here, and I got a little loop tight in there, and so I can take this 1 kilogram mass and I can put it right here. Okay, now what I'm going to do, and you can see that this mass is free to swing back and forth. How's that look? Looks pretty good? Okay. So this mass can swing back and forth, and we're going to study this from the point of view of energy here in a minute. But what I'm going to do is I'm going to place this up to my mouth, like this, and then I'm going to release it. And then I'm going to try not to flinch when it comes back. Are you ready? Okay. So this takes a lot of faith in the conservation of mechanical energy. Okay, ready? Let's see, 1, 2, 3. Ah! Ah! Ow! Okay, now, why? Okay, my reflexes. I want to flinch, but I know I can do it. Why is that? Because when I release this, what's the maximum height that can go back up to? The height where I released it. Okay, and this has to do with conservation of mechanical energy. I know that when I release this mass, it can't come back and go higher unless one of you clowns pushed on it or something, adding energy to the system. Energy is conserved in this system. There is a little tiny bit of friction, right? Woo. And so if I wait long enough, this thing will stop oscillating. It'll come to rest. But it might take a long, long time. Because where is the energy going? Okay, when I release it, well, what kind of energy does it have when it's at the top up here? What kind of energy? Yeah, gravitational potential energy. And some of that gravitational potential energy turns into what when it's down here and moving fast? What is the energy that's contained in an object when it has mass and it's moving? Kinetic energy. And then it swings back up and becomes what again? Gravitational, and then it becomes what again? Kinetic, and then it's back up to gravitational potential energy. Nowhere is anybody, once I release this, nowhere is anybody adding energy to the system. It's just oscillating back and forth between gravitational and kinetic energy. So when it comes back up here, it doesn't have more energy than it started. Can't create or destroy energy. And so, now, there is a little bit of wind resistance, isn't there? So when this is released, it stirs up the air. The object, as it moves through the air, does work on the air, and that takes away some of its energy. It transfers its energy from its motion into the motion of the air. So it has less energy when it comes back. So if anything, it's going to come back a little bit lower than when I released it, but not much lower. And we will see how long. Woo! Okay, you can try this. Now, if you try it, be careful, okay? But you can try it. Just don't lean forward. I did have one freshman kid. I used to do this with my freshmen. And you know what he did? He held it up to his mouth like this, and then he pushed it, which is not a good idea. Because when I push it, what am I doing? What is a force through a displacement? Work. So I'm transferring energy from my arm into this thing. So now it's not only got gravitational potential energy, but it's got the work that I pushed into it. And so now it's going to come back higher, okay, than I released it. So don't push on it when you try this. Okay, that's it.